The aircraft is lined up on the runway. Inside the cockpit of a Boeing 737, everything feels calm. This is where aviation becomes fascinating, because the answer explains not only how airplanes fly, but how every pilot actually controls an aircraft, from takeoff to landing. Before an aircraft can fly, it first needs one thing: airspeed. And to gain airspeed, it needs thrust. If it's a propeller aircraft, the spinning propeller accelerates a large mass of air backward. If it's a jet aircraft, the engines compress incoming air, mix it with fuel, ignite the mixture, and expel hot exhaust gases at tremendous speed. As thrust increases, the aircraft accelerates down the runway during the takeoff roll. The faster it moves, the greater the airflow over the wings. Relative wind is simply the airflow moving directly opposite the aircraft's flight path. Every wing, every flap, and every flight control responds to this airflow. As the aircraft moves forward, its wings meet the airflow at a small angle known as the angle of attack. The wing's shape, called an airfoil, changes the way air flows around it. Air accelerates over the curved upper surface, creating lower pressure. Below the wing, pressure remains comparatively higher. This pressure difference helps pull the wing upward. At the same time, the wing continuously redirects air downward. These two effects work together to create lift. As airspeed increases, lift increases too. The pilot gently pulls back on the control yoke. The elevator raises the nose. The angle of attack increases. The wings generate enough lift, and the aircraft becomes airborne. The elevator is attached to the horizontal stabilizer at the tail of the aircraft. When the pilot pulls back on the control yoke, the elevator deflects upward. This increases downward aerodynamic force on the tail. As the tail moves downward, the nose rotates upward around the aircraft's center of gravity. If the pilot pushes the yoke forward, the elevator deflects downward. The tail rises. The nose lowers. The aircraft changes pitch attitude and begins descending. Turns begin with the ailerons. They are located near the outer edges of each wing. Suppose the pilot wants to turn right. The right aileron moves upward. The left aileron moves downward. The right wing produces slightly less lift. The left wing produces slightly more lift. The rudder is mounted on the vertical stabilizer. Its job is to control yaw. Yaw is the side-to-side movement of the aircraft's nose. If the rudder moves left, the tail moves right and the nose yaws left. If it moves right, the nose yaws right. The rudder is also essential during crosswind takeoffs and landings, and for maintaining directional control on the ground. Extending flaps increases the wing's camber, or curvature. This allows the wing to generate more lift at lower speeds. That is why aircraft can safely take off and land at slower speeds. Picture this: an eagle flying low over open meadows. Not rushing, not flapping aggressively, just gliding, reading the invisible movement of the air beneath its wings. Now shift your view. Above the clouds, a commercial airliner begins to emerge. First, just a shape. Then a powerful machine breaking through soft white layers of cloud. Two completely different forms of flight, but governed by the same invisible physics. Nature perfected it first. We simply learned how to join it. And if this video changed the way you see airplanes, then the sky will never look the same